then she lets go and Jack falls into the ocean and dies.
But wouldn't they have just accounted for how many people were on board and then accounted for them in lifeboats? Or if some smart person had invented the GPS sooner, they would know to stay out of range of that area?
Probably, but this is a movie. You want action, drama, and tragedy. Not to see a boring old movie without anything riveting. They want to be on the edge of the seat, not watching a documentary.
Yeah, you're right. Let's keep going.
Interesting.
Yeah,
Have you ever wondered
time
what
that
the world
boat we
would
were
look
on
like if
sank?
we had
Yeah,
salt?
but it was really easy to get off. There are exactly as many lifeboats as we needed.
That trip was so fun. Here, far, wherever you are, I believe that the heart does go on.
See, everybody would be a whole lot happier if people had just taken the time to use some maths and prevented horrific disasters. In fact, in order to prove to you that maths really can solve almost all problems, let's have a look at 2 other disasters that good old numbers and trigonometry could have stopped.
First up, it's the Turkish Airlines Flight 981.
Architecture from France, a design flew on the Douglas DC-10 led the aircraft carrying 335 passengers and 11 crew to crash in the forest in northern Paris.
Just minutes after the plane took off, the rear left cargo door blew off due to a problem with how it was designed. It was able to be forced shut by baggage handlers without the pins locking correctly, and it blowing off caused an explosion in the cabin and severed cables linking to the flight deck with the aircraft's elevators, rudder, and 2 of the 3 engines. This could have been prevented by redesigning the measurements and unsafe construction of the door. The design should have been run past multiple engineers and other tests before making the change to ensure proper locking mechanisms. Consequently, many lives were lost, even though better designing could have completely avoided this horrible accident.
The final disaster is the Minnesota Bridge collapse.
On August 1st, 2007, the central span of Minnesota Bridge suddenly gave way, followed by the adjoining beams. The structure and deck collapsed into the river and onto the roof banks below, the south part toppling eastward in the process. A total of 111 vehicles were involved, seeing their occupants and 18 construction workers as far as 35 metres downwards. Northern sections fell into a rally-out, landing on 3 unoccupied freight cars.
The Mississippi River Bridge was an 8-lane steel truss arch bridge that went across the St. Anthony Falls of the Mississippi River. The bridge was Minnesota's 3rd busiest, carrying 140,000 vehicles daily. Like most other bridges, it gradually gained weight during its use, as workers installed concrete structures to separate the different lanes, adding strain to a weak spot. At the time of the collapse, crews had brought tons of new materials and equipment onto the deck for a repair job.
The error with the bridge was the designers had installed a metal plate that was too thin to support the weight it needed to. The plate had to support a force that was too heavy for its compressive strength. Compressive strength is the capacity of a material or structure to withstand loads tending to reduce size, as opposed to tensile strength, which withstands loads tending to elongate. Compressive strength involves testing and calculating how well a given specimen, product, or material can survive compressive stress. Unlike tension, which expands or pulls, compression means a specimen, product, or material is shortened or pressed down.
Compressive strength of a material is the point at which the material fails. Calculating compressive strength involves testing to find this failure point and using the data from the test to feed the calculation. The final compressive strength number is in kilos force per square centimeters or PSI.
To calculate the compressive strength, you need the formula S equals P divided by A, where S is the compressive strength, P is the maximum load that can be applied to the specimen before it collapses, and A is the area of the specimen. Your final compressive strength value will be in units of PSI. For example, if the maximum amount of force an object can bear is 24 newtons and its area is 2 meters squared, then 24 divided by 2 equals 12. Therefore, the compressive strength of the object is 12 PSI. The designers of the Minnesota Bridge should have run these tests on all of the components of the design, including the plate that caused the collapse. They also needed to install a plate that had a higher compressive strength in order to account for the extra weight that was inevitably going to be installed in the future.
Well, if they did that, then the ship's departure would have been delayed for weeks.
Can we just make the movie already, please?